Okay, example 3, carbon dating. It says, estimate the age of a newly discovered fossil in which the ratio of carbon-14 to carbon-12 is R equals 1 over 10 to the 14th, and that the carbon dating model is R equals 1 over 10 to the 12th times E raised to the negative T divided by 8,223. So we see here that we've got this equation, and I know what R is because they told me here, and I'm after the age, so I must be looking for T. So let's just plug in and solve for T. So we end up with 1 over 10 to the 14th equals 1 over 10 to the 12th times E raised to the negative T divided by 8,223. Well, remember, we won't need to solve for t, which is caught in the exponent. So we're going to have to get our exponential piece by itself. So I need to get rid of that fraction at the beginning. Well, I don't like the denominator, so I can multiply by it to get rid of it. And since it has a 1 on the top, that makes it nice because 1 times anything would just be the anything. So I multiply both sides by 10 to the 12th. So I end up with, on the left-hand side, 10 to the 12th divided by 10 to the 14th equals, and on the right-hand side, we have that e to the negative t divided by 8,223. Well, usually we see our exponential piece on the left, so I'm going to switch that over. So e to the negative t divided by 8,223. And we can work out the left-hand side there, that 10 to the 12th divided by 10 to the 14th. Well, let's see if I come over here real quick in a little think bubble. 10 to the 12 over 10 to the 14th. Remember, when you divide, subtract the exponents. So that's 10 to the negative 2. Negative exponent, send it to the bottom. So that's 1 over 10 squared, which is 1 over 100. Or if you want to use the decimal form, it's just 0.01. So I'll finish out my little think bubble. Excuse me. All right, so I end up with 0.01. Now, how can I get that variable out of the exponent? Well, you've got two choices. You can log both sides, or this is an exponential form, so you can set it up into log form. Well, the last example, I took it from exponential to log, so this time I'm going to go ahead and just log both sides. So I'm going to log both sides, but I'm going to use a natural log because we have an e in this problem. So I got the natural log of e to the negative t divided by 8,223 equals, remember what you do to one side, you have to do to the other. Because we did this now, we can take this exponent here and we can bungee it in front of its log. So let's see, I'm going to have to move up here so I've got some room to write. So I end up with, oh, this looks pretty messy, I'm sorry. But we've got negative t over 8,223 natural log of e equals the natural log of 0.01. Well, we know the natural log of e is what? It's 1. So that's gone. And now I just want to get rid of that negative and that 8,223 that's on bottom. So let's multiply both sides by negative 8,223. And I do apologize, this is really messy looking. And I'm multiplying over here. This is not an exponent, even though I wrote it kind of high there. Alright, so my numbers and my negatives cancel, and I get t equals, and over here I have negative 8,223 times the natural log of 0.01. So we put that into our calculator, and we get 37,868.314 years. Now, yes, that is a big number, but remember we're talking about a fossil, so it's probably a pretty young fossil, I don't know. But we do expect it to be a large number. All right.